Hello and welcome to the 7th session of the Massive Open Online course, the 11th iteration for the master's degree in digital currencies for the University of Nicosia. I'm Andreas Antonopoulos, and I'll be answering all of your questions from the last week. This is the final session of this course that I'm participating in, so it's been a very fun course so far. I have lots of questions, but since this is the last session, let's also ask questions on the chat room. So let me know if you can hear me on the chat room, first of all. Let's make sure that the video and audio is good. And we'll get started right away. Yeah, very good. People can hear me OK. First question comes from Marios. Marios asks, can you explain the process from the time an Ethereum user wants to execute a smart contract until it is uploaded on the blockchain, executed, and displayed on a valid block? That's a great question, Marios. First of all, in order to explain this, keep in mind that there are effectively 3 different types of transactions in Ethereum. The first one is a straight payment. That's a transaction that happens from a regular account, or as it's known in Ethereum, an externally owned account, or EOA, to another externally owned account, basically from a private key, public key pair that a user has to another private key, public key pair in the form of an Ethereum address to another user. So this is just a payment from one user to another, from one address to another, exactly the same as you see in a Bitcoin transaction. There's another type of transaction where you send payment and data, or both, not to another user, but instead to the address of a contract. So this is a big distinction in Ethereum between an address that belongs to a user that has a private public key behind it, an externally owned address, or EOA as it's known, or an address that belongs to a contract which does not have a private key behind it. It's run by the code in the contract. So an address that's run by a contract can receive a transaction, and this transaction may include data that tells it what to do, or a payment. And that's how you make a contract run in Ethereum. You send a transaction to the contract address, and instead of that going to the address of a user, it goes to the address of a contract where the contract executes with that input. Finally, there's a third type of transaction, a kind of special transaction, which is sending data to the 0 address. And what that does is it registers a contract for the first time. So let's put all of those ideas together and explain the process from the moment an Ethereum user wants to run a contract. Now, let's say that contract doesn't exist. Well, the first thing they would need to do is write the contract, compile it, create the code for the contract, then embed the contract in a special transaction to the 0 address, and pay to get that contract mined. Now, at this point, what that will do is it will create an address for the contract, and it will record the code of the contract onto the blockchain. So now the contract can be run. To run the contract, any user would then send a transaction to the address of the contract. And that transaction can contain some value, like a payment. It can also contain some data, and the data may call one of the functions in the contract. Or it can contain both value, payment, and data at the same time. Once a user sends a transaction to the address of a contract, the Ethereum virtual machine, and this applies to other blockchains that use a virtual machine, will start executing the contract, passing the transaction as input to it, so that the contract knows what to run. And then that execution happens under the consensus rules, and it causes changes to the state of the contract. It might cause the contract to make a payment, to call other contracts, to run a function, to update some internal data, etc., etc. All of these things happen as a direct result of that transaction to the contract, which is what causes it to run. So every contract runs when it's triggered by a transaction and using that transaction's input as its input. A contract doesn't run on its own. Contracts never run on their own. They have to be triggered by a transaction. And before that even happens, the contract has to first be registered with the Ethereum blockchain. Very good. Marios asks, have you heard about Vitalik's new proposal to impose gas fees on wallet transactions to fund developers? What is this about? Strictly speaking, this is a bit off topic, but I'll answer it quickly. There is a proposal in the Ethereum community that was started by Vitalik to have as a common practice, not as a rule of the protocol, not as a rule imposed by consensus, but simply as a common practice, have every wallet impose a slight fee on every transaction, a voluntary fee, that funds developers in the protocol, or at least funds wallet development. Now, this is something that also happens in Bitcoin. There are wallets where when you make a transaction, you have the option to also make a donation or add a small fee that goes to wallet developers. Usually that's done with a payment channel. Sometimes it's done with a straight Bitcoin transaction. In Lightning wallets, it's done, again, with a payment channel. This isn't different in any way. What Vitalik proposed, however, was to make this part of the best practices so that the development of wallet software is better funded. Now, this is a problem in many blockchains. Wallets represent the cutting edge, the front end, of user interface development. And a feature that is designed into the protocol or the consensus layer, for example, doesn't really become active until a wallet can use it and exposes that to users in a way that's intuitive. So even though something may be available, let's take an example. In Bitcoin, for example, native SegWit addresses that start with BC1. Have you seen one of those? You probably haven't. Why? Because probably about 80% of wallets don't yet implement them. Only a few wallets implement them at the moment. So even though that feature has existed now for more than 6 months in the base protocol, its implementation in wallets is still lagging. This is a problem across all blockchains, and the problem is that wallets are not very well funded. Most wallets are available for free, and they have to make money by advertising, by selling other services and things like that. So that's Vitalik's proposal: better funded wallets, better developed wallets through a mechanism of voluntary fees that are added to transactions. And another question from Marios. Marios asks, can you explain the Monero ring signatures? I can try my best to explain the Monero ring signatures. Now, Monero uses a rather different and very interesting mechanism to protect the privacy of transactions. There are a number of different coins or blockchains that are specialized in privacy, and they use different techniques. Some of these techniques involve encrypting the values. This is what you see with things like zero-knowledge snarks that are used in Zcash and other protocols. Some are about mixing inputs, which is what Bitcoin does with CoinJoin, although that's not a mandatory feature. And some involve some combination of that, such as maybe confidential transactions. That's a proposal to be added to CoinJoin. Ring signatures do. Monero ring signatures are a mechanism of privacy where in every transaction, you engage multiple inputs from the blockchain. Let's say Bob wants to make a payment to Catalina. And Bob has a Monero wallet and has a payment output, unspent payment output that they want to spend and send to Catalina. Now, in a traditional transaction, there'd be a transaction with one input, Bob's input, and one output that goes to Catalina, maybe some change. That's the normal structure. In Monero, however, when making a transaction, you decide how many, or your wallet decides how many other participants will be in the transaction. So in that transaction, there will be one input from Bob, but there'll also be, let's say, another 4 inputs from 4 other unspent outputs on the blockchain, which do not belong to Bob. Essentially, it looks like a coin join. It looks like there are 5 participants in this transaction. This happens with every transaction in Monero, however. So all of the transactions have one real input and the number of decoy inputs. Now, keep in mind, these are not other users making payments. Instead, what happens in Monero is the Monero system can basically use outputs that are on the blockchain to obfuscate the source of your transaction without involving those other users. Then a signature is created, and this is called a ring signature, which is like a signature that's produced from for all 5 of the outputs. Signatures produced from all 5 of the inputs that are involved in that transaction, 4 of which are fake decoys, and 1 of which is real. And that signature validates, but you can't tell from the signature which of the inputs is real and which ones are fake, which means that you don't know who made this transaction. Now, you apply this across the board to a lot of transactions. It makes it very, very difficult to do analytics, because every transaction comes from, apparently, multiple different people. It doesn't. All of them are decoys except one, but you can't tell which one is the decoy. Now, you might be thinking, well, hang on a second. If you can involve other outputs in your transaction, and those outputs might be spent or not spent, how do you know that they're not being double spent? This is where another technology comes into Monero, which is the ability to have essentially a key image, which allows you to record whether an output has been spent or not, but without being able to tell which output that is. And so with that technique, you can prevent double spending, but you can also mix these decoy inputs into each Monero transaction, which greatly increases the privacy of the system. So it's like a massive coin join that happens on every transaction all of the time. One of the things to realize is that in terms of technologies like CoinJoin, there's a very big difference in how effective these technologies are, depending on how many people use them. If you're only one of 100 people who uses a coin mixing or coin join technique in order to obfuscate the source and destination of your coins, if you use these privacy techniques, but you're part of a very small group, well, the set of outputs that are involved in coin join and the set of participants is small. It's a lot easier to do statistical analysis on that, especially if the payment amounts differ. But if every transaction and every user is involved in every time in a coin join, then that creates a much more powerful privacy technology. And that's the basis of what Monero does. All right, let me check in with the chat room, see if everybody can hear. How are things? Let me just make sure everybody can hear and see me okay, and we'll continue with the next question. I know we had a tiny bit of an interruption. Audio's good. Fantastic. Let's continue. Steve asks, can you explain how a user can define the gas price they have paid for a transaction, and if not enough gas, the transaction will fail to be processed? Is there an advantage to always put more than what is required in order to get the transaction processed faster? Steve, when you create a transaction in an Ethereum wallet, your wallet gets to set 2 parameters. One is the gas price, and the other one is the gas limit. The gas price creates essentially an exchange rate between gas and ether. Gas is not ether, but gas is used to measure ether, meaning that, or rather, gas is priced in ether. So for example, you say how much gas you want to put in, and then each gas unit has a price in Ether, and that price in Ether determines how much you're willing to spend in total to have that transaction processed. If you have enough in your limit, then that transaction will be processed, and you will be charged how much gas you actually used in your transaction, which depends on what contracts you're executing or what payments you're making. For example, a simple payment costs 21,000 units of gas. Now, when you create a transaction, you can set not the amount of gas, because that's really about whether it will execute or not, but you can also set the gas price in order to prioritize your transaction vis-a-vis the other transactions. In that way, it works very similar to Bitcoin fees. So the way gas works in Ethereum has similarities to the way Bitcoin fees work. But there are some important differences. So by putting a higher amount of gas in your transaction, you make it more enticing to miners so that they will mine it at a higher priority or sooner than if you have a lower price. And again, this mostly matters when the blockchain is operating at or near capacity, at which point there are more transactions than can fit in each block, and some have to be prioritized over others. Gas determines that. There's a separate question, however, in Ethereum, which is the gas limit. You've got to understand that one of the things that gas does in Ethereum is it prevents unlimited computation or denial of service attacks. That's its most important function. And it does that because in Ethereum, processing a contract, a transaction that leads to running a contract, could run forever. It could involve other contracts. It could create loops. It can just keep running and consuming memory, updating data, and trying to do a lot of different things. And because everybody has to run that transaction and that contract in order to participate in consensus, that means using a lot of resources on the system. In order to prevent runaway or abusive transactions and contracts that use too much computing, you have gas. So it's basically a system of controlling how many resources are being used. This is different from its function as a fee. The function as a fee to prioritize is one thing. But again, the ultimate function is to set a limit on the maximum amount of computation you're willing to pay for. So as a user, when you send a transaction or when your wallet creates a transaction, you or your wallet gets to decide how much maximum amount of gas you're willing to spend in order to get this transaction processed by the network. The network will take that maximum amount of gas from your account when the transaction starts executing, and then will gradually count how much of it you're using. If you run out of gas mid-computation, you're going to get an error. The transaction is going to get rejected. You will lose your gas. You will pay the fee, and your transaction won't actually run. If you have enough gas, because you set a high gas limit, then your transaction will execute, and you'll be charged only for the amount of gas that you actually use. So that's how the function works. Remember, gas does two things in Ethereum, unlike Bitcoin fees that do one. It's used to prioritize transactions when the blockchain is at or near capacity by ensuring that the transactions that are more important, because people are willing to pay more for their gas, are processed faster and prioritized. Secondly, and the main function of gas, is to control how many resources the Ethereum blockchain spends on validating transactions by putting a limit on how much computation and data storage operations happen in the form of gas. Andreas asks, why are applications migrating and being built on Tron or EOS instead of Ethereum? Andreas, it's very difficult to really be able to tell why a certain project will choose to use one blockchain instead of another. It depends on a lot of different factors. It depends on, for example, the type of blockchain it is and whether it has certain capabilities or features that are useful in a specific application. So let's say, for example, the developers building an application that has a very important privacy component may use a blockchain that has stronger privacy guarantees. Or maybe they'll use a blockchain that does better microtransactions, or has more capacity, or has better decentralization capabilities. Or the opposite, is more centralized and therefore more suitable for their centralized application. Each developer group will obviously make these choices among a variety of blockchains that are available. And it's difficult from the outside to know why those choices were being made. Some of them are purely ideological. People may have vested interests in certain blockchains. They may be invested in them monetarily. Or they may have some ideological reason to prefer one versus another. It might have nothing to do with the technology. It might have to do with loyalty towards other people they know, or perhaps the strategy that that blockchain is pursuing. Stephen asks, should we consider the number of dApps on a blockchain, the number of commits on the code, the blockchain activity, and the peer-to-peer account numbers of cryptos as valid performance indicators? Stephen, it really depends on what you're trying to achieve. Performance indicators tell you something about the blockchain, but they also tell you a lot about the person who chose the performance indicators. If I look at which performance indicators you're interested in, I will be able to tell what's important to you in terms of a blockchain. Is it important as an investment? Is it something where you're looking for future increases in value? Are you looking at performance metrics that tell you whether it is sufficiently decentralized, or whether it is actively developed, showing a lot of innovation in the community, et cetera, et cetera? Now, it depends. If you're a trader, if you're a developer, if you're interested in the technology, if you're interested in it as an investment or as part of your portfolio, you're going to choose different metrics. And so it depends really on what you consider good performance. What is the best blockchain, which depends on what you're trying to do with it. I've talked about this in the past, which is that we all have different metrics for success. To me, for example, the blockchain that has the most money invested into it isn't necessarily the most interesting blockchain. If that blockchain is centralized and run by a bank, of course it has lots of money invested into it. That's what banks have, lots of money. That doesn't make it the blockchain that delivers the most freedom, or the most political empowerment, or the most economic inclusion to people. It does not develop the most innovation. And so those metrics are more important to me than other metrics. In general, however, it's difficult in many cases to measure these things accurately. Like, what does it mean to look at the number of commits? How do you value code based on metrics of commits? What if a lot of these commits are changing the spelling of words in comments? Or do you count lines? What if it's written in a more expressive language where you need fewer lines? Does that mean it's a less valid project? Probably the opposite. If you write your project in assembly, then your commits will have a lot of line changes, but that doesn't make it any better. It just means that the language you're using is more verbose and less expressive. So, it's really difficult to pick any kind of metric. And in fact, in this industry, we see a lot of people trying to attach themselves to certain metrics or argue certain metrics. And really, that reveals their biases rather than any useful information about which blockchain is working. In the day, what really matters is which of these systems solves a problem for you better than any of the other systems that you've used as a user, as a developer, as someone who's making dApps perhaps, or someone who's just using it to do something, maybe cross-border transactions, micropayments, whatever. All of those things will determine which blockchain is good for you. So your criteria are different from everybody else's. again, part of that is not seeing this as an investment zero-sum game where one system wins and another system loses. Floris asks, I mine Digibyte with an Antminer L3 script miner, but it's also possible to mine it with an Antminer S9 SHA-256 miner. So how is the validation of the transaction on these multiple algorithm coins work? So Floris, transactions are validated the same way. What we're talking about here is some blockchains have algorithms for consensus mining algorithms that involve more than one algorithm. Some of them use a rotating set of algorithms so that they're constantly making it difficult for miners to specialize in only one type of ASIC and dominate the market. The idea generally here is to increase decentralization by forcing miners to diversify their equipment and introducing kind of a broader playing field for these mining algorithms. That's one of the technologies or one of the design trade-offs that some blockchains make. Now, I don't know if that actually helps to increase decentralization. That's really an argument that needs to be made more clearly, at least from my perspective. But essentially, this has nothing to do with validation of transactions. Transactions are validated exactly the same way. What's different is the mining of blocks. And in this case, these blocks are mined either with a rotating set of algorithms or with multiple algorithms operating simultaneously, kind of like a merged mining system. Franco asks, is the IOTA tangle considered a blockchain? And if so, how secure is it? The tangle that's used in IOTA isn't, strictly speaking, a blockchain because it's not really a chain of blocks. Instead, it's a mechanism for sequencing transactions that's distinct from a blockchain and considered by those who are involved in IOTA superior to a blockchain. The idea here is that you weave a tangle of different chains together, and these are, as far as I understand it, chains of transactions, not blocks. It's a different way of doing consensus and recording the time sequencing of transactions. It's different from a blockchain. But in terms of its practical use, it behaves very similar to a blockchain. So a lot of people just call that a blockchain too, just because blockchain means this cryptography-based distributed consensus thing, rather than an actual chain of blocks with hashes. So an IOTA tangle is not a blockchain, but it's equivalent in many ways to a blockchain. How secure is it? I don't really know. It's very difficult to measure that. In terms of security, really the question is it more or less secure than other approaches? And I don't have the necessary information to make that kind of comparison. It's what you can see, however, is that as long as there is some money stored in on an IOTA tangle or any other tangle, and that money is still there and hasn't been stolen, well, that's how secure it is. Maybe there's $1 billion there. Well, it's $1 billion secure. You can measure the security by proxy by looking at how much money is on the table for someone who was able to break the consensus algorithm and steal from the blockchain. And if there's a lot of money, then that likely tells you that even motivated attackers have not been able to compromise the system. Johnny asks, how is it possible that certain projects like Rootstock attempt to run smart contracts on Bitcoin? Does the programming language used in Bitcoin allow this? Would it be scalable? Johnny, projects like Rootstock do not run smart contracts on Bitcoin, but rather they use a sidechain approach where Bitcoin can be converted to an equivalent unit on the rootstock sidechain, where smart contracts run as part of the consensus rules. And then when the smart contract is finished, then that unit can be moved back into Bitcoin. So it's like a two-way peg of currencies that can move back and forth between two side chains. In the case of rootstock, they're called drive chains, but effectively it's the same general concept. So rootstock has a separate blockchain. That blockchain is mined with a different algorithm. It's a federated mechanism as far as I know at the moment. And it's connected to the Bitcoin blockchain, but these smart contracts do not run on top of the Bitcoin blockchain. The programming language used in Bitcoin allows you to make some very basic and rudimentary smart contracts. Now, these are powerful enough that with combinations of techniques like multisig and time locks, you can do some very interesting things. The Lightning Network, for example, you can build some rather sophisticated smart contracts and financial instruments with Bitcoin, but there are limits. There are significant limits in there. One of the most important limits is that because Bitcoin's script-based language is constrained, strongly constrained in the way it runs, it doesn't allow you the full flexibility of a Turing-complete language like that, which is used, for example, in Ethereum smart contracts. So you can't just do anything. You're limited by the constraints of the language. That's a design trade-off that is very deliberate. That deliberate design trade-off ensures that Bitcoin has a much higher level of security because simple smart contracts that operate in a very predictable way, simple scripts as exist in Bitcoin, can be made more robust faster than complex and flexible scripts or programming languages that are used in smart contract blockchains, where the process of achieving security requires more iterations and more maturity because there's more things that can go wrong. And we see that, for example, a good example of that is the difference in implementation of multisig in Bitcoin versus multisig in a smart contract mechanism. Multisig in Bitcoin has been around for the early days. It's very secure. It has never had a bug that breached the security or lost funds from multisig. That's because it's implemented in the consensus layer with a script that is extremely simple and processed in an extremely simple way. And it's got a lot of limitations. There are very few things you can do with a straightforward, simple multisig M event. That's it. Multisig in Ethereum, which has a lot more flexibility, has been developed independently by lots of different smart contract developers. Some of those multisig scripts have failed, and with dramatic results and loss of funds. So that shows a bit the difference in the security trade-offs. Now, that doesn't mean you can't make secure smart contracts. It just means that they take a lot longer to reach a level of maturity where they can be trusted. You need more iterations. It needs more maturity because it has more flexibility. Johnny asks, does Bitcoin Cash also aim to run smart contracts? Yes, kind of. Mostly what people call smart contracts in Bitcoin Cash are small extensions to the scripting language to allow a few more functions. Some people have claimed that that it's possible or desirable to turn the Bitcoin script language into a Turing-complete language in order to make more complex smart contracts. I think that's the wrong trade-off for security. I think it introduces all kinds of other problems, which are better solved by blockchains that deliberately make that choice in order to run flexible smart contracts. In the case of Bitcoin Cash, really what most people are calling smart contracts is not that different from the simplistic smart contracts you see in Bitcoin. Bitcoin Cash has a couple of new opcodes that can do some more sophisticated things. I believe they're re-enabling some of the earlier disabled opcodes from Satoshi's early days. And part of the reason for that is to do more smart contracts. Another use of another application for smart contracts is the use of op return. And I believe that Bitcoin Cash has increased the amount of data that can be embedded in the blockchain with an op return. Again, all of these things are not the type of Turing-complete compiled smart contracts that you see in Ethereum, Tron, EOS, Ethereum Classic, etc. But they're more kind of just stretching the amount of work that can be done in a non-Turing complete scripting language like Bitcoin's. So we'll see how that works out. Again, I think these trade-offs are rather deliberate. So this is not a case of one system can do everything. If you hear people telling you that Ethereum can do great, super flexible smart contracts and robust nation-state resistant sound money without security problems, and Bitcoin can do super robust, secure sound money and also super flexible smart contracts, generally speaking, when you hear that, people don't understand the engineering trade-offs involved. Because there are engineering trade-offs. And when you get a bit more of one thing, you have to get a bit less of another. You don't get to maximize both. So I don't know how that plays out. It really depends on what the implementation details are. All right. Let's see if there are any follow-up questions. Give me a second, just reading through the chat. I think we've covered everything we're going to cover for today. So we're going to end this a tiny bit early in terms of the questions we have from today. Again, we started a bit late. I'm going to do one more question, and then we'll get, it's a bit off topic, but I'll do it anyway. Ravi asks, we have many blockchains with different consensus mechanisms. Creators of these projects spend more time ranting about other projects than working on innovation. What are your thoughts on the crypto holy wars? Do monetary benefits, are monetary benefits the reason for the holy wars? And doesn't this hurt innovation? Ravi, the thing is, we do see a lot of this maximalism, tribalism, holy wars emerging in crypto. This has really been happening since the very early days, even back in 2013, 2012, when I first got involved. Already some of these were raging. I noticed that these get worse during times when the market prices of blockchains are low. And I think that's when people get more defensive and more insecure about their own choices. And they feel the need to defend those choices by attacking alternative projects. So it seems to me that a lot of this happens as an emotional response to being under pressure or feeling that your choices might be wrong or have been challenged by others. The truth is that most cryptos coexist happily. There's certainly enough growth in this market that it isn't a zero-sum game. And in fact, because of the open source nature of development, happening in another crypto allows developers to both use the good ideas by copying code, really, because open source is open, and allowing experiments to run in different chains and watching the outcomes, but also learn from the bad ideas and the mistakes so that you don't repeat them in your own blockchain. There's so much opportunity here for innovation that feeds across projects where everyone benefits from the increased innovation, from trying different approaches, from trying different ideas in a very broad and diverse way, where everybody gets to try their idea. Everybody has different ideas about what the applications are and what the principles are, etc. So having a broad ecosystem encourages that. I think it's a complete waste of time to be attacking projects. You hear a lot of people saying that essentially they're providing a public service. They're warning people about the projects that are likely to use to make them lose money or to be a bad investment. Honestly, that's concern trolling. It's not genuine, at least in my opinion. People need to learn how to invest their money themselves. Having influence or popular personalities on Twitter or things like that endorse one project or bash another and give investment advice or warn newbies to stay away from one thing or another. A lot of that's self-serving, and to me, it doesn't seem very productive. People can make their own choices. People should make their own choices and learn from their successes or mistakes on their own. Relying on other people to tell them what is good and what is bad is a form of centralization. Trying to become a popular expert only then to turn around and endorse projects or bash other projects as not worthy is basically appeal to authority, which is a kind of cognitive bias that causes people to make mistakes. So from that perspective, I don't think it's particularly helpful to be bashing other projects. I think it's important to criticize when you see fraudulent behavior, yes. But there is a very fine line there between seeing fraudulent behavior that is obvious and malicious and calling that out, and then seeing fraudulent behavior everywhere and calling everything a scam except for the one project that you're interested in. I think that's not particularly helpful, and it's not productive. But, hey, people are going to keep doing what they want to do. So who am I to tell them otherwise? We're going to keep seeing holy wars. There isn't a single social phenomenon, human culture, or society that doesn't have this kind of fractionism and infighting. And so we will see that here, just like we see it in every other industry. I'm sure in the plumbing industry, there are holy wars over the benefits of copper pipes versus PVC flanges that erupt at conferences with people calling other people frauds because they chose PVC over copper. I don't know, probably. Thank you so much for attending. This was session 7, my last session for the massive open online course, the University of Nicosia's master's degree in digital currencies. I'm Andreas Antonopoulos. I'll see not you, but other students next semester, because all of you will pass and move on to do other exciting things. Of course, if you want to take the course again, you're welcome to do so. I will see you then in the next MOOC. It's been a pleasure answering your questions. Thank you for attending. Sorry for the slight technical delays this morning, and enjoy the rest of your week.